Hello everyone. How are we all doing? How's everything been? How was the last week class? I hope it was easy. I hope it was understandable. So this week we're going to be talking about data encryption basics. So let's get to it. So the objective is to understand the basic concept of data encryption and its importance, identify the different types of encryption, discuss hash function and its role in ensuring data integrity, explore how encryption protects data at rest and in transit, and identify tools and software used for implementing encryption in different environments. So let's get to it. So today we're going to be talking about data encryption. And in today's world where everything is connected together, where everybody is sharing information, right? Data encryption plays like a very important role when it comes to safeguarding sensitive data from unauthorized access. So when you want to safeguard information from someone that is not meant to have access to that information, encryption is very useful. So data encryption is the process of converting data from its original form, known as plain text, into an unreadable format called ciphertext. This transformation ensures that only authorized parties with the correct key can decipher the encrypted data back to its original form. So data encryption entails converting data. Let's say let's use I want to send a message meet meet me don't mind that I'm slow, meet at noon. So I want to send this message now, meet at noon, right? So encryption means that this meet at noon, I finish writing it oh. When I want to send it, it's going to convert this meet at noon now, this data now, meet at noon. It's going to convert it into something unreadable when it is transferring the data to the person that I want the data to go to. So maybe to transfer it to something like XY, A, D, O, 1, 7, something unreadable. So the goal is that it wants to transfer or like data encryption simply means that you are converting this data, this meet at noon, that is the original form of the data, into a cipher data, into something unreadable. So this information, now somebody says information and they don't know what exactly I'm talking about, but this is meet at that I'm trying to communicate. And then if the person that I'm sending the information to has the right key, has the key that can be used to unlock this data, so the person can now be able to unlock this data and get back my original context, which is meet at noon. So that is what data encryption entails. So data encryption means that okay, you have a plain text, you have an information, you want to convert that information to something unreadable so that if somebody that does not have access, that is not meant to have access to that information, gets the information, maybe by doing man in the middle attack, or maybe by so just something, or maybe by doing something else, and the person gets access to that information, the person will still not be able to understand what that information means because that information has been encrypted. So that's what data encryption entails. So why is data encryption important? So data encryption is important to protect sensitive information from different range of threats, things like data breaches. For example, now maybe an attacker can attack an organization and steal all their data in their databases. But if those information are encrypted, if they are not stored in plain text, you understand, the attacker might not be able to have anything to do, might not be able to do anything with that information that he has gotten. Why is that? Because there's encryption on that particular database, you get. So even though the information has been leaked, that is data breach, even though unauthorized person has gotten access to that information, right? um the unauthorized person, they cannot still be able to know exactly what is inside that database or know exactly what is inside that information. So the next thing is cyber attacks. So encryption protects against eavesdropping, where attacker intercepts and monitor communication. So an attacker can just decide that, you know what, I'm going to intercept, like let's say person A and person B are communicating, and then so attacker can just say, okay, I'm going to intercept. So if this is A and if this is B and they are talking to each other, they are sending things to each other, they're just communicating. And attacker can come and be here now and trying to be getting all the information, that whatever information is passing through A, it will get it. Whatever information that is passing through B, it will get it. That's what an attacker wants to do, right? That's when you are eavesdropping or when you are doing man in the middle attack. But when you have encryption, even though the person is getting this information, the person cannot do anything with this information because it's encrypted. You understand? The information will probably not make sense to the attacker. The next thing is data corruption. Encryption prevents unauthorized notification or tampering of sensitive information. Let's say for example now there is a code, a very important code. Let's say code to unlock a bomb, right? If let's say there's a bomb somewhere now, there's a code to unlock a bomb and to stop the bomb from exploding. And the bomb team finally figure out the code and they want to send it to the people on site. You get, an attacker might want to go inside and change that code so that they can input the wrong code. But when you have encryption, right, when they check, when they are what they call it, when they are is dropping or when they are doing an individual attack and they want to make modifications, number one, they might not be able to do any modification because they might not understand what is inside that data. Number two, if they make modification, there's a way that the person on the receiving end can be able to confirm and know that okay, this file has been modified. So that is the power of encryption. Then the next one is identity theft. So in the world where now, like, we are doing almost everything online, your financial data is online, your login credential is online and stuff like that. So data encryption prevents, like for example, if another thing, let's use data breach for example now. An organization, a financial organization that deal with users information, users data like your BVN, your NIN, your name, where you are born, your local government, state of origin. If they are storing those data encrypted on the database, even though there is a data breach, the attacker cannot go and steal one person's identity from that data. Why is that? Is because there is encryption. So when there's encryption, whatever data that the attacker has stolen will not make sense to the attacker. So therefore, he will not be able to steal the identity of any user on that system. So then, what are the significance of data encryption in data security? Number one, confidentiality. So encryption secures data by ensuring it's unreadable to anyone without decrypting key. So confidentiality means that okay, this information we want to be confidential. We don't want information to be for everybody. It's a sensitive information, right? So encryption will ensure that even if somebody have access to it, it is unreadable. So you get, so without the encryption, without the decryption key, the information is unreadable, which ensures confidentiality. And the next one is protection of personal information. In this era that we live in now, where personal information is frequently exchanged, right? Encryption helps to safeguard sensitive details like social security number, your NIN, your BVN, your financial information, your health record from criminals or unauthorized users. Then the next one is secure communication. So encrypting data during transmission over the network um prevent interception of by attackers or eavesdroppers. Exactly. So secure communication. So if I'm talking to, if person B or person A and person B are communicating and through a secured communication channel, and that secure communication channel encrypts all the data. Whatever that A is sending to B is encrypted. Whatever B is sending to A is encrypted. So even if somebody comes in the middle now, the person will not understand what is being communicated because what is here has been encrypted. You get. And the next one is compliance with regulations. So we have a lot of regulatory body, right? Many laws and regulations like GDPR, HIPAA, etc. mandate protection of sensitive data. So these bodies and ask that okay, your data should be secured. If you are dealing with financial data, it should be secured. If you are dealing with health data, it should be secured. You understand? If you are collecting personal information, it should be secured. And for you to do that, this is where encryption come into play again. So data encryption will help you to be compliant. Remember that if you are not compliant, you'll be sued, and sometimes you'll be charged with a fine to pay because you are not compliant. So you have to make sure you are compliant. And how can you make sure you are compliant? Using data encryption. Hope this helps. All right, let's go to the next one. So more significant, data integrity. So for example, now there are ways. So data encryption helps to ensure the integrity of data by detecting any unauthorized modification. So for example, now if um I want to send meet me, I want to send noon to somebody now. I want to send noon, okay, meet me at noon, right? And then while along the line when it was sending, it got modified, and now this person is seeing night here, this person is seeing night. So the person can be able to detect, especially if you are using hash functions, right? Person can be able to detect that okay, oh, there was a modification made to this particular data that was sent, because person can see that okay, the hash function is different, the hash of the message I got is different. You understand? So there's a way to actually check that okay, there's a way to actually check that okay, data has been compromised, and this will help with data integrity. So when you will see that okay, this thing has been compromised, you know that okay, that this data is not the right data, so it protects data, it helps with data integrity. So the next one is the protection against data breaches. So in events of data breach, encryption data is significantly harder for attacker to exploit. We said it before that once data has been breached, right, and the data is encrypted, it's very difficult for the attacker to exploit it. You get, because they can't have access to information only if they go and find the decryption key. You understand? And finding the decryption key can take a while, a lot of process and stuff like that. So it protects against data breaches. And next one is safe storage. So safe storage means that okay, let's say you are storing information on your laptop, or you are storing data on a drive, we are storing data in a database. So safe storage means that okay, if you're encrypting that data, it brings an additional layer of security. So let's say somebody go and steal your laptop, or somebody go and steal the hard drive, you understand? The data there is still encrypted, which means that the person cannot still have access to it. Even though the person has physically taken away the property, even though the person has physically taken away like the device, right? Because that data is encrypted, it will be difficult for the person to see what is actually on the drive. So this can help organizations, especially when they do bring your own device to work. You can ensure that okay, as everybody bring their own device, that whatever they are storing on their device is actually secured, it's actually encrypted, so that in case the staff of the organization lose their device, the organization can either wipe out the hard drive, so that all their all their information will not be available to anybody, or knowing that the fact that this data on the laptop or on the hard disk are encrypted, it means that whoever is on the receiving end, or whoever that's storing this data, will not have access to this information. Two types. So we are going to types of encryption. So we have two types of encryption. We have symmetric encryption and we have asymmetric encryption. There are other types of encryption as well, right? So for symmetric encryption, it means that we have a single key. So a single key is what is used for both encryption and decryption. Let's say you have a particular data now. You have meet me at noon now. So you can use one particular key to encrypt meet me at noon to whatever to make it unreadable, right? To make it unreadable. And then you can now use that same key to now make what was unreadable back to readable. So let's say for example you have meet me at noon. Let me just use noon because it's too long to write. Let me meet me at noon. We have noon now. And now we now encrypt this data, and it's now showing X, Y, A, W, right? So it's now showing XYAW now, right? So what happened is that we are using a single key for symmetric, which means that we are just using one key to encrypt this data to make it unreadable. I will still use that same key to decrypt this data to make it readable. You get? So basically you're using just one key to convert the readable data to unreadable, and then you're using the same key to convert the unreadable data back to readable. You understand? So that is for symmetric. So symmetric makes use of single key. Then when the process entails when data needs to be encrypted, the encoded is encoding using this shared key, right? Transforming it into an unreadable format, which is the ciphertext. To decrypt the data back to its original form, the same key is used, exactly what I explained. So what happens is that you want to convert your plain text to ciphertext, you use just one key. So just one key, you just use that one key. You are moving from plain text to ciphertext. And when you want to move from ciphertext back to plain text, you use that same one key, not a different key, that same key. You understand? Then key distribution. So one of the challenges with symmetric encryption is securing the distribution of the shared key between parties. So obviously you are communicating between two different parties. The one goal of symmetric encryption is to ensure that it's really those with the authorized key that can decrypt your message that you've already sent, right? So one of the challenges that symmetric encryption entails is the fact that how do you ensure the distribution of that key? How do you ensure that the key to encrypt and decrypt data is secured between the two parties? So we have common examples of symmetric encryption. We have the AES, which is Advanced Encryption Standard. We have the DES, which is Data Encryption Standard, and we have 3DES, which is the Triple Data Encryption Standard. So these are some of the examples of algorithms of encryption, the of symmetric encryption algorithm. Now, the use cases of symmetric encryption is often used for secure data transmission, file encryption, ensuring data confidentiality. So one of the use cases is that you use symmetric encryption for data transmission, for file encryption, and to ensure that your data is confidential. It is also effective for large volumes of data because it is fast. Since you're using one key, it has good speed and it's also simple. And we are going next to asymmetric encryption. So asymmetric encryption is often called public key encryption. So for asymmetric, it means that we are using a pair of keys. So we need a private key and we need a public key. So the public key, as the name suggests, is openly distributed and used by anyone to encrypt the data. However, the corresponding private key, which is kept secret by its owner, is used for decryption. So how asymmetric encryption works is that you have maybe, let's say I have something I want to send now. I want to send noon. I want to say we meet at noon. You meet me at noon, right? And then I'm going to encrypt it to something else. Let's say WXY. Uh, let's say this is our cipher data now. This is what we've encrypted it to. So the way it is that for asymmetric, the public key is known to everybody. So anybody can use this public key and encrypt their data, right? While the person that needs to decrypt the data is now the one that has the private key. So the person that needs to see, okay, I want to know, okay, what does this data mean, is the one that has the private key. So the key go hand in hand. So the public and the private key go hand in hand. So the public key is used for encrypting the data, while the private key is used for decrypting the data. Key usage. Data encrypted with the public key can only be decrypted with the matching private key and vice versa. So if you encrypt data with the public key, you must use a matching private key to decrypt that data. Security and key distribution. Asymmetric encryption addresses the key distribution challenge that the symmetric encryption have, because there is no need to share the private key. Then common um asymmetric encryptions are RSA, which is called reverse schema adema. So this is named after the people that generated this type of encryption. Then we have the ECC, which is elliptic curve cryptography, and we have DSA, which is digital signature algorithm. So use cases, it is used to for secure key exchange, it is used for digital signature, and it is used to establish secure communication channels. So it's also used for secure online transactions, like when you're doing your bank transfers and the rest. It's used when you're doing when you maybe you're communicating with SMS, and when you're communicating like WhatsApp and the rest. So basically it's used for things like that. So these are the differences between your symmetric encryption and your asymmetric encryption. So for symmetric encryption, use a single key. Asymmetric encryption, you use key pair. That means you use public and private IP. So for number of keys, we have one key for symmetric, which is for both encryption and decryption. And for number of keys for asymmetric, we have two keys. So we need public and private key. So you can just look through this table. You just for symmetric is faster and more efficient when it comes to speed, while asymmetric is a bit slower due to complex mathematical operations. So just look through this table, get a feel of it, understand and see the differences between the symmetric and asymmetric encryption. So the next thing we are going to is hash function. This is another type of encryption. So hash functions are mathematical algorithms that take input data and produce a fixed size string of characters, typically a hash value or hash code. So let me explain it. So let's say for example now I want to hash a password. Let's say my password is Adele, Adele, Adele 4. Adele 4. This is my password, Adele 4. And a hash function is a mathematical algorithm that takes this input of a data and bring out a hash value of that data. So it might be 17A P O6. So this might be the hash value. Do you understand? So basically what it does is that it takes in it's a mathematical algorithm. It takes in um your input data and produce a hash value. So this hash value is usually a fixed set of strings. So it depends on the kind of hash you are using. It might be a 256 bits of data. You understand? So it is fixed. You understand? The length is fixed. Let me just go through the characteristics of hash. So it's consistent. No matter how many times you give the same thing to a hash function, it will spit out the same code or the same hash. So for example, if I put Adele 6, it's going to give me the same code. If I put Adele 6, Adele 6, Adele 6, I will still get the same code. You understand? So that is why they say it is consistent. It's not if I put Adele 6 in the morning, it will change the code. I still put the same Adele 6 in the evening. No, it's the same. So anytime I put Adele 6, I will always get the same code. And the next one is one size fits all. The hash function always makes secret code that are the same length, no matter if your message is short or really long. Let's say, for example, I put in this message, meet me at noon, right? It's going to give me the same character length of hashes or the same character length of the hash as it will give me if I say noon. So for example, if I say meet me at noon and it produces about, let's say, 128 characters. So you know what characters are. The characters are things like A, B, C, 1, 2, capital letter A, capital letter D. That's characters. So let's say for example now I put meet me at noon, right? And it does bring out about more than 28 characters. If I still write noon, it will still give me that 128 characters. Do you get? So no matter how long or short your text is, it's going to give you the same length. You get? So the next characteristic is secret code maker. So once your message become a secret code, it is super hard to figure out what the original code was. It's more of like a one-way street. So you can make a hash value of something, you can create a hash for something, but it's difficult for you to go from the hash value back to the code. So let's say I put noon. Let's say I put noon now, and the noon ended up being so many things. I cannot go from this so many things back to noon. You get? So hash functions are different from doing asymmetric and symmetric encryption, because those ones you can go back and forth, you can encrypt and decrypt. While for hash functions, it's a one-way street. While the next thing is uniqueness. It's like the hash function makes secret codes that are incredibly unique. It's extremely rare for two different messages to have the same secret code. So let's say for example, I put miss me at 12 p.m. and then I change that P to A and I say meet me at 12 a.m. There's no way those two codes will be the same thing. The two hash functions will be different. And this is how you can check that a data is being tampered. Because let's say, for example, you already know, okay, this is how the hash is supposed to be, right? If the data is now being tampered, you can be able to compare hashes and say, oh, this hash is different from the hash I got before. So, what is the role and the function of what is the role of hash functions in ensuring data integrity? Number one, we have data verification. So by generating a unique hash value for a specific set of data, hash function serves as a fingerprint for that data. Any alteration in the data, even a minor change, results in a completely different hash. By comparing values before and after transmission or storage, data integrity is verified. So basically, I explained this. Let me explain it again. So let's say, for example, now I sent a message, meet me at 12 a.m., and that has become a hash value, and I've kept it, and I want to transmit that data around. When I transmit that data and it gets to the person that transmitting it, and they see that the hash has changed, maybe it was intercepted one way or the other, and then it was changed from P to A, you understand, and it hadn't changed. You can be able to tell because it has value become extremely different. It will be different from what you already have before. And the next one is digital signature. Hash functions are used in digital signature schemes. A sender can hash a message or document and then encrypt the hash value with their private key, forming a digital signature. So if you want to have a digital signature, you want to make sure that okay, this is a digital signature, this is just from you, right? So what the sender can do is that you will hash the content of the message, right? And encrypt a hash value with that private key. So let's say you have a hash value, you now add that hash value to the private key. This will now form a digital signature. You understand? And the recipient can decrypt the signature using the sender's public key and verify the message integrity by comparing the decrypted hash value with the newly hash value from the received message. It's basically the compare and contrast stuff. So the next one is for secure password storage. This is very important. This is what people have been using now for storing their passwords on the database. Basically, what it is that hash datas are when um when an actual password wants to be stored on the database, right? The password is hashed so that when the user wants to log in, right, the system will compare the hash value of what the user is logging in compared to what is being stored in the database. Do you get it? So let's say for example, the first time you log in and save the first time you log in or you create an account with, let's say you're creating an account with Microsoft or something, you put your password as Adele6. So it creates a hash value of that Adele6 and stores it on the database. The next time you want to log in now and you put Adele6, one of the characteristics of hash function is that no matter how many times you put a particular information, it will be the same hash, right? If you put address in the morning to be the same hash, if you put address in the night to be the same hash, there's no change. So what will happen is that it will check that adult six out. Okay, this adult six hash now, is it the same thing with the adult six hash that was stored on the database? If they are the same, that is when you say okay, you can log in. But if they are different, then it's not that it is wrong password. Why is that? Because the hash values are different. So the next thing is blockchain technology. So in blockchain technology, each block in the blockchain technology contains a hash value of the previous block, creating an immutable chain. So if there is any change of a block, it will alter the hash, breaking the continuity and indicating tampering. So this is how you can know, okay, that this blockchain has been tampered with if there's an alternation in the hash, understand, in the hash of that blockchain. So this is how this is the role of the hash function when it comes to data integrity. So real world application of encryption now. So for the real world application of encryption, we have things like our messaging app. So things like for secure communication, we have messaging apps, things like WhatsApp, Zenda, Signal. So Signal is also a messaging app. Telegram. They use end-to-end encryption to ensure that it is only the sender and the receiver that can access the messages. You get only the sender and the receiver can access messages. So if I'm sending something to my brother now on WhatsApp, it's only him, only me and him should be able to see that message. Even though maybe even though I'm using MTN or even though I'm using Airtel should not have access, should not be able to see my message. That's like if I'm using this, if I'm connected to my company's Wi-Fi, they should not be able to see that message. That is called end-to-end encryption. Then for emails, we use things like services like Proton Mail or PGP. That's pretty good privacy for email encryption to protect the content of email from unauthorized access. So when you send email to somebody, only you that is sending the email and the person that is on that tool that should receive that email. Do you understand? Only those set of people should be the ones to receive that email. So it protects unauthorized people from accessing, will prevent unauthorized people from accessing the information on the email. And the next thing we have is financial transactions. So online banking use things like secure socket layer SSL encryption, which ensures online banking transaction and ensures that sensitive financial data remains confidential. You get. So using SSL, that's secure socket layer encryption, ensures that online transactions are secured. Online transactions remain confidential. The sensitive financial data are confidential and they are not exposed just to anyone. And people that are connecting to you in the same network should not be able to see your financial transactions. So the next point is cryptocurrency. So things like blockchain. Talk about how hash helps with blockchain technology. So it's employ encryption to ensure transaction in cryptocurrencies like Bitcoin, Ethereum are secured and transparent transaction. So you can be able to say, okay, this hash value change, that means this is a fraud. You understand? So if that is how like people can check, okay, this blockchain transaction is a fraudulent transaction. This is how they can check that it's a fraudulent transaction, because you can be able to compare hash values and say, okay, is this right? Is this not right? And the next one is data storage. So cloud services, providers like Google Drive, Dropbox, iCloud, they use encryption to protect data and ensure privacy and security even if the server is compromised. So even if their server is compromised, they want to ensure that the data that's on that server is not compromised as well. If somebody breach into their server, right? Let's say somebody finally have access to their server that stores people's financial record. They want that those financial records should not be compromised as well. Even if the attacker have access, the attacker can should not be able to read those information. You get. So for disk encryption, that is hard disk encryption. We use things like BitLocker for Windows. So BitLocker ensures that um whatever that is on that disk is secured. You understand? For Mac, we use things like file vaults to ensure that the entire disk is encrypted. So if the data is stolen, if the device is stolen, you or if the device is lost, rest assured that nobody have access to the contents on that particular disk or that particular device. So how encryption protects data at rest or in transit? So for data at rest means things that are stored on your on your devices, things that are stored on the databases, things that are stored on the server or any storage medium. You understand? So what when you say data at rest, it means that data is not doing any work. Data is being stored. Data is not moving from one person to another. You understand? So that is when you see data at rest. So it means data is maybe stored on your hard drive, data is stored on your phone, data is stored in the database, data is stored on the server. It means that data is not moving anywhere. You understand? So for how does encryption protect data that is at rest? So for disk encryption, we've talked about things like BitLocker, fault vault, file vault, and de-encrypt. So these are what we use to store to encrypt disks. When you're talking about a disk, it means like a storage unit, a physical storage unit. You understand? So your hard disk is a storage unit, you get. So on Windows, they use things like BitLocker to lock that particular hard disk. So even though that hard disk is stolen, you understand, even though the hard disk is stolen, you can plug the hard disk, but to ask for a certain pin or to ask you for a pin. And if you don't have that pin, you can't access that data that is inside that hard drive. For file vault, the same thing. If you don't have access, if you don't have the pin, if you don't have a way to encrypt or a way to decrypt that hard drive, you can't have access to the data that's on that hard drive. Instead, so that is what we call disk encryption. It means that okay, if your data is stolen, if your device is missing, it's like if that particular hard disk is missing, your data is still secure, the data is still safe. Understand? Because it becomes useless to them. The only thing you can do is to wipe out your data. You understand? So the next thing is database encryption. Database encryption, encrypting data within database prevent unauthorized access to sensitive information, even if someone gains access to that database. So let's say for example now, people's username and password are being stored on the server or the database, right? Database encryption entails that let's say an attacker making mouth on Twitter, oh I'm going to hack your organization, oh I'm going to get on your user data, oh this or that. And let's say the person now has succeeds that gets access to database. Database encryption is in the sense that okay, the person has access to your database, the person can download the information, maybe can even know the information, but the person cannot understand what they are seeing. Maybe everything will be you looking scattered or looking somehow. So even though the person has gained access to the database, the person cannot still understand what is on the database. That is what it entails when you say database encryption. It means that the information that is being stored on that database is secured. The same way we talked about hash functions when we talk about data. When I talked about when you are signing in to somewhere. So when you first log in, or when you first create an account on any software, the the information is supposed to be stored on a database. Yes, so stored on a database. So that when next you come and log in, they'll be able to remember you. They're able to say, okay, this person has created an account. For that to work, you need to store the password. But if you're storing the password, you're storing the password in a plain text. That means if someone put their password as Adele 1234, you will go on the sheet on the database and you still see Adele 1234. So the goal is that okay, it will be Adele 1234 that the person will put in, but then the value will now be hashed and stored in database as a hashed value. That way, if somebody download your data or if someone have access to a database, person will not be able to see that and they want to treat for as the value. So the next thing is cloud storage encryption. The services like Google Drive, Dropbox, AWS, they encrypt their data in their server. The goal is if I am breached, the data should not still be readable. Do you understand? And the next one is file level encryption. So this is when you're encrypting specific files. You know it's possible now that you right click and you password a file. That's a form of encryption. You password your Excel document, password whatever document that you have. This is giving it additional layer of security that okay, oh, I know that this is encrypted, but even though it's encrypted, I want to still password, I want to still encrypt those files that are on that system. You get. So data in transit. So what they say when somebody say data in transit, what does it mean? It means that data is moving. It means that data is being transferred from one person to another. It's in the network or in the communications channel. So if I'm sending a message to my brother now, data is in transit. If I'm making a phone call, data is in transit. If I'm downloading information, the process of downloading that information, data is in transit. If I'm uploading information, the process of uploading that information, data is in transit. If I'm sending that email, the process of sending that email, like when you press send, that time thing moves from your mail to the other person's mail, data is in transit. So how do you protect data that are in transit? Number one, we have the SSL, which is the secure socket layer, or we have the transport layer security protocol, which encrypt data during communication between web browsers and servers. This protects online transactions, login credentials, and other sensitive information exchanged over the internet. So basically, it encrypts data during communication. And we have the VPN encryption. VPN means virtual private network, and it uses encryption to create a secure tunnel, ensuring data remains confidential while transmitting between a user device and the VPN server. So the VPN, we talked about virtual private network, and this means that okay, it's going to create a secure channel where data can be transmitted, right? And it's ensuring that data that is being transmitted between the device, user device, and the VPN is actually secured. So that is the work of VPN encryption. And the next one is email encryption. So end-to-end encryptions or protocol like STAR-TTLS encrypts email communication, securing the content of the email from interception. So the moment you press send, right, end-to-end encryption is in place to ensure that okay, nobody intercepts this email. Then the same thing with messaging apps like WhatsApp, Signals, and Telegram. So they use end-to-end encryption just to ensure that okay, the message that is being sent, excuse me, the message that is being sent, right, from the sender to the receiver, it's not being compromised. So this is how data is protected at rest and in transit. So at rest, by using things like um disk encryption, by using things like a BitLocker, by using things like database encryption, by using hash functions, while in transit, by using things like the VPN encryption, the email encryption, the messaging app encryption. So tools and software used for implementing encryption in different environments. So we're just highlighting them now. So for this encryption, we use for Windows, we use BitLocker. For Mac, we use File and Vault. For Linux, makes use of okay, we have VeraCrypt. So this VeraCrypt is for both Windows, Mac, and Linux. So these are just some of the disk encryption that somebody can make use of when you want to do encryption for disks, hard disks, and the rest. While database encryption, we have things like Oracle Advanced Security, we have Microsoft SQL, Server Transparent Data Encryption, we have MSQL encryption, enterprise encryption. Again, so these are the some of the database encryption tools that we can use. While the cloud storage encryption tools, so we have things like Amazon S3 server-side encryption, we have Google Cloud Storage encryption, we have the Azure Storage Service encryption. But these are some of the tools and some of the softwares that this cloud storage make use of for encryption. Then for communication encryption, we have things like OpenSSL, we have things like OpenSSH, we have things like GNUPG. So these are the communication protocols that are used to ensure encryption. You understand? So these are just this is just things that you should know, not something that you need to like cram your head about, but it's just good to know just in case. Maybe as you look at it, you learn it from time to time, you might need to like make use of it. So the next one for email and messaging, we have things like Proton Mail, we have things like Signals, then we have things like PGP/GPG. So PGP is a pretty good privacy. So it's used for email encryption. Even Proton Mail is used for email encryption as well. Then we have the VPN encryption. We have OpenVPN, we have WireGuard. So it's an open source VPN protocol. You understand? So these are just different tools and different softwares that can be used for encryption. So you can just look at it. Doesn't you don't need to like learn any proper thing. Just good to know. You get. So what are the key takeaways to get from this information from this class? So encryption is the process of transforming data from its original form, which is known as a plain text, into an unreadable format, which is known as a cipher text. So encryption is the process you are transforming original text, what you want to send, into an unreadable format so that somebody else cannot read it. So encryption algorithms are mathematical processes that are used to encrypt and decrypt data. So we talked about encryption algorithms, how we have how they are mathematical processes and they are used for the encryption and the decryption. So what is doing the encryption and the decryption is actually called an encryption algorithm. We'll talk further more about it in the next class. And then we have symmetric encryption. So we talked about symmetric encryption, which is a type of encryption that use just one key, just a single secret key for both encryption and decryption. While asymmetric encryption makes use of a key pair. So a private key for encryption and a public key for encryption and a private key for decryption. So it has to be a pair. So it has to be a corresponding pair. If there are two different pairs, like it won't work. So plays a crucial role in safeguarding data integrity, confidentiality, and availability. Encryption protects data at rest, that is when data is stored on the device or when it's stored on the cloud, when it's stored on a disk, when it's stored in database, and when it's in transit, that is when data is traveling from one person to another, from one network to another. Now, the various tools and softwares are available for implementing encryption in different environments, from your personal computers to like large enterprise network. So personally, you can actually enable BitLocker if you're using Windows, right? To encrypt your data on your device you get. So from large organizations to personal persons, you can actually just implement encryption just to make your information more secured. So discussion. Have you ever encountered a situation you felt that the need for data encryption in your personal or professional life? Has it ever occurred to you that something happened that made you decide that okay, I think we should have just encrypted this data. I think this data should have just been encrypted. You understand? The next question is, why is it essential to secure data at rest? That's a stored data using encryption. Can you give examples of how this is beneficial? So why is it important that okay, if data is on the database, if data is in your phone, if data is in your on your laptop, on your disk, why should you encrypt the data? Why shouldn't you just only bother with where you are transferring the data? Why must you store the data while it's at rest? Why? You understand? And give example why you think that's actually good to do that. Then what are the main differences between symmetric and asymmetric encryption? So remember we showed a table that showed the differences. So just look to the table and remind yourself, okay, but these are the main differences. So if you have any questions, don't forget to send the questions to this link. Then assignments. So can encryption be broken? Right? Can maybe you encrypt a data, you convert the data, you've encrypted the data now. Can somebody that does not have the key decrypt that data? And how can it be decrypt? How can it be broken? How can somebody that's not supposed to have access break that your encryption? Let's say somebody finally has access to your laptop and they realize that okay, your laptop is encrypted, or maybe somebody finally have access to an organization's database and realize that this database is encrypted. Can somebody break it? Can somebody do something in a way where they can have access to that information even though the data has been encrypted? So what are the key challenges or drawback associated with implementing encryption? We talked about encryption, we talked about okay, these are the types of encryption, these are the benefits of encryption. So are there challenges that somebody will face when they are trying to implement encryption in an environment? So just think about it, research about it, and just put up your answer. Thank you very much. Do have a wonderful day. Bye.